Hello, my name is Damien Weiss and I'm the development team manager for Moodle. I gave a presentation to the Hackfest at the Australian Moodlemoot last week, and it was an introduction to writing interface uh, in a Moodle plugin using all of the new rendering technology that we added in Moodle 2.9. So that includes um, AMD JavaScript modules, jQuery templates, uh, and Ajax web services. And for the people who weren't at the Moot, I thought I would make this recording and cover that information again because it was good for introductory for new developers, and also it's good information for people who've been building Moodle plugins for a long time to see how all the new technology fits together. So the way that I ran that presentation is I have some Moodle GitHub branches which are available at this URL. So this is the first branch, and it's just available on my GitHub account. Just here, so you could there's only one commit in this branch, so you could just cherry pick the latest commit from this branch. Or if you don't know how to use Git, you could download the zip and then just take this one folder, because all the code is kept in this one folder. There's a local Hackfest folder, and this contains all the code that we're going to be changing and modifying in this presentation. So if you're familiar with Moodle development, this is a standard structure for writing a plugin. This is the same folder here. So you can see the files that are listed there are just the basic starting point for building a plugin in Moodle. So we have version.php, which lists the plugin version, lists the Moodle version that's required to install the plugin, and also says the name of the component, which is the Frankenstyle plugin name. The next thing you can see is there's a language file which has language strings. That's if you don't know how the language strings work, there's lots of documentation in the Moodle dev docs, but they're very simple. Now the next thing we're going to look at is the index page. So first thing that all entry points pages in Moodle need to do is this require the config file. That has to be the first thing that they do, and from that point on they'll have various globals set up. And so once they've included the config file, they need to set up some variables in the global page object, which is here. So they need to set the context if they're not calling require login. So if you recall require login, that will call set context for you, but every page needs a context so that it can perform access checks and set up the navigation. The next thing is needs to call set URL. Now this URL should be a URL that exists in the nav tree in order for the nav tree and the breadcrumbs to function. So the way Moodle works is it looks for the URL of the current page in the nav tree and then highlights that node as so you can see where you are. And it also builds the breadcrumbs from that location in the nav tree. Finally, you need to call set title and set heading for the page. Normally they would be different, but this is just a demo. And then the next thing is you need to use a renderer to print out the header for the page. In this example, we've used page get renderer, and then used our plugin name here, and that will get the renderer specific for this plugin. And then we call output header. Output is our renderer, header is the function that writes out the JavaScript, the titles of the pages, and sets up the DOM ready to insert the main content. Then we have created, this is a class that I'll show you in a minute. This is a renderable. So we have a renderer here, and this is a renderable. A renderable is just data that gets passed to a renderer to produce HTML. So the renderer render method accepts a renderable, and that prints out, well, that returns HTML, which we echo into the page. And finally, we always have to print a footer on every page. So the footer is important because that we insert JavaScript in the footer of the page, and this also adds all the block regions and closes off the HTML tags for the page. If you're ever writing a plugin and you're wondering why the blocks aren't showing up or the JavaScript's not working, it could be that you've forgotten to print the footer. So in here we have a renderable, which I'll show you now. So far we haven't done anything with the renderable. So this renderable is set up ready for us to template, but by default a renderable doesn't implement any methods. It just contains data, so it's not expected to have any particular functions. It's just expected that the renderable is the data that you pass to the renderer. Templatable is a new interface that we've added in 2.9, which lets you create a renderable in a standard way that can be sent to the render from template functions, which will use the mustache templates, which I'll show you soon. In this example, we are creating export for template, which flattens the data in the renderer into a format that can be, it's really flat, it contains no classes, it can just, and it's ready to be passed to JSON encode and decode, because with our new template system, we want all the data to be able to be sent to JavaScript as well as to PHP. So we need to have a stricter definition for exporting the data. It has to be JSON encodable, so only simple types, basically, arrays and strings and integers. Next is, I'll show you our renderer. So every plugin can have a renderer, or they can have more than one renderer, and the location for the renderer is used to be renderer.php in the root of the plugin, but now that we can use namespaces and auto-loaded classes, output is the API for rendering things, so this is the correct namespace for having a plugin renderer. So this is our renderer, it's called renderer, and it extends plugin renderer base, so all your plugins should extend that same renderer. And it has one function, render index page. So we remember index page was the type of our renderable, and a renderer is supposed to have this magical render underscore and then the type of every renderable in your plugin that you want to generate HTML for. Now the contents of this render function will look a little bit different to what you've seen in Moodle versions before 2.9. But what it's calling is, it's telling the renderable to export its data so that in a flat form so that it can be rendered from a template. And now our renderer also has a new functionality in that it can render this data from a template stored on disk. So this is a mustache template, which I'll show you in a second. but this is the new templating engine that we have for 2.9. So we've shown you everything except for the new template, which is here. So all of this is comments except for the last 3 lines. These 3 lines. And there's no mustache tags in this 3 lines, so it just looks like plain HTML, which it is. You'll notice that we have a comment, a mustache comment here. So mustache comments start with 2 curly braces and an exclamation, like this. And the format of the comment is that it has @template and then the component name for our plugin and then the template name here. And what this does is we have a template library in Moodle 2.9. This one. And for every template in our Moodle installation, it will show up here, and this tool will actually look for that comment in the template. When it finds the comment, it will use it as the documentation for the template. Okay, so what this tool told us is that we can insert this syntax to provide an example context when rendering the template using this admin tool. The reason for that is that this template library is designed so that once we have a large set of templates in Moodle, you'll be able to see any template in here and also see an example of how it will look in the current page. That's important because it lets you see that, firstly, when you're writing templates, it lets you test that the template is going to work in right to left or in different themes. And it means that a theme designer can write a new theme and they can test all of the templates on the system in one place without having to navigate to every page in Moodle. So if they test that all of the templates in Moodle look good on their new theme, then all of Moodle should look correct using their theme. So this is just showing you a very basic starting point where we have a single page. It has a renderable that is getting rendered, and that is being rendered with a template. So that's as simple as you get. It's just basically all of that structure is there, and the end result is that we get a simple page which looks like this. Okay, so it's not a very exciting example, but it works. So the next thing that we're going to do is show you that we're rendering this with a template in PHP, but if we expose the data for our template via a web service, we're also going to make this example a little bit more complex, just to show the reason why we need a Ajax web service and things like that. But so the first thing is what we want to do is take one of our existing Moodle web services and make it available to call from Ajax. So done this already, so I'm just going to switch branches. Okay, so now we have switched branches. There's basically one more commit on this branch, which we can see here. So if you've written any web services before, you'll know sort of how you write a web service in Moodle. Nothing has changed to how you do that. For this demo, I have cheated a little bit. Instead of writing a brand new web service, I just took one of the existing web services in Moodle and added a little bit more data to the result that you get back from it, and have just wrapped it in my plugin. So the way that you write a web service in Moodle is you create this DB services file in your plugin, and you list all of the functions for your new web service. And then for each function, you have to say what class provides that function and what method in the class provides the web service function. So in this case, I've put all my external functions in this one external class inside my plugin, and then the method that I'm exposing is called getSiteInfo. The name of the web service will be local Hackfest getSiteInfo. And it's public, basically. So this is the external class that I added. So each web service that you add needs to have the name of the function is getSiteInfo, but there needs to be getSiteInfo parameters, which describes the format of all the arguments for the external lib function. Needs to be the actual function itself, getSiteInfo, and getSiteInfo returns, which returns a structure which describes the return of the function. Now, there's one more function in here, which is new for 2.9, which is this getSiteInfo is allowed from Ajax. What that does is, by default, web service functions aren't available to call from JavaScript because that might be a security risk. For example, you might have a bunch of web service functions that you added in order to integrate with an external student record system or enrollment system, and you don't want students to be able to just run JavaScript and query those functions. So by default, web service functions are not available to JavaScript. But if you're writing your own web service functions, you are the one that can make the decision that this function is safe to call from JavaScript. So by adding this function, you mark that function as safe, and we will let you call it. So the other thing that I added in this commit is I put some more interesting data in my renderable. So now my renderable has returns all the data from that core web service as data, and it also adds in another key with the current time and a random number. So the reason that I put the random number on the end is so you can see it change when you refresh the page. But what we're going to do now, so this web service will be available now in my Moodle site, and I could call it from JavaScript, but I haven't actually written any JavaScript that calls it. So now we'll switch onto the final branch, which just has one more commit. Okay, so there's a few things that we've done. Now, because we can call this web service function with the data, we're going to modify the template to add a bit of interactivity to the template. So first thing is, let's have a look at the template. Before it was very simple, but we've modified the template so that it's actually going to be printing some of the data from the context. So whenever you see these two curly braces, either the open or close ones, that's going to be a mustache tag. So the way that works is you pass data to the template that it renders, and in the template it can print out variables, it can loop over variables, it can perform simple conditional logic, so it can say if a variable is true, then print this block of text. If it's false, print something else. And there's also some helpers that you can insert in the template. So in this example, we've got a string helper, which is going to use our Moodle language strings to look up the refresh string and insert the text here. And we also can use this to insert blocks of JavaScript in our template. And the reason that we have a tag for that is that the JavaScript won't actually get inserted in that spot in the page, because that would be slow in terms of rendering performance. As soon as you put a block of JavaScript in the page, that JavaScript needs to run before the rest of the page will be rendered by the browser. So we defer all the JavaScript that we insert in the page until the very bottom of the page, which means that the whole page will appear, and then all the JavaScript will run later. So the next thing is that in this bit of JavaScript, we have a couple of things going on. We're using require.js to load in a JavaScript module like this. So the syntax is you go require and you pass in an array of the modules that you want to load. And then for each module, this is the module, we get that module as an argument to the function closure from that call. So refresh here is now our module, and refresh has one function called refresh that we want to call. So that's a way to push, keep the JavaScript out of the page, but we just put in basically one dependency in the template to kick off the JavaScript. So that JavaScript module that we were talking about is in here. So in our plugin, we have an AMD folder, which stands for Asynchronous Module Definition, which is a standard format for JavaScript modules. We chose that format over some of the other ones because it is stable and it's the best format for web applications at the moment. So Node.js tends to use CommonJS, which is a slightly different syntax. And the new JavaScript format that's coming out is ECMAScript 6, but that's not finalized yet and it's not stable yet. So we went with the most stable, and the one that you can find all your third-party libraries already exist in AMD format. And the way that it works in Moodle is that you just put your modules in your AMD/source folder. The name of the module is just the file name, so it's very simple. So the AMD format always starts with a define. So this is defining our module. The first argument is an array of dependencies. So we'll see the first dependency there is jQuery, and all the ones that start with core are ones that are written by Moodle, and they are shipped in the lib AMD source folder. So once we've listed all our dependencies, then we get a closure, and the arguments for that closure are all of the modules that we depended on. So require.js will load all those modules before this module will execute. So we get jQuery, Ajax, template, notification. Now, this is an example of a very, very simple format for JavaScript modules. So all it is whatever you return from your closure becomes your module. In this case, we're returning return. This is a JavaScript object with one key, which is a function. So it's basically returning one function called refresh. This is our refresh function, which we're using jQuery on because it's available in the scope of our whole module. We are looking for that refresh button that we've added to a page, and we're adding a click handler. When you click on the button, we're going to call ajax.call. Now, ajax.call is a function that we have added which lets you call web services from JavaScript. So all of the hard work about security, creating a PHP endpoint for the Ajax request, all of that is taken care of now. And it has other benefits as well. So you'll notice that this function takes an array of objects. The reason for that is that you can pass more than one function to this method, and it will call all of the web service functions in turn and return you all of the results as an array. So if any of those web service functions throw an exception, it will return exceptions for the rest of the web service functions. And this also uses promises. So promises is a feature that's in jQuery, but what it means is that you can write code that will actually run asynchronously, but you can structure it a bit like synchronous code. You can read it like synchronous code. So this ajax.call function actually returns an array of promises. And because we only passed one method to the ajax.call, the first promise that we get back is going to be the one that relates to that method. So a promise you can call .done to add a handler that will get called when the promise is successful, or you can call .fail to add a handler that will get called when the promise catches an exception. So we have this notification.exception, which is a generic exception handler, which will show you a dialog with all the details of the exception if you need to use it. So following the logic through, we have now called this web service, and we got back the data from that web service. And now we can render it. So templates.render is, again, that's a new core AMD module that we have written. And it will render the exact same template that we were rendering from PHP in JavaScript with the data that we just got from the same web service. So everything that we were doing in PHP, we can now do in JavaScript. We'll notice that this templates.render returns as a promise, so it's all consistent. And the arguments for our promise is the HTML and JavaScript that was returned by the template. So remember, our template had a block of JavaScript in it that will actually be separated out from the rest of the HTML. And so we can replace a part of the page with our new HTML, and then we can also run any JavaScript that was returned by the template. So in the case of our template, that means that it's going to replace the template in the page with some new HTML. In the process, that would destroy any click handlers that was on the refresh button. But because we're running the JavaScript from the template again, it's going to put the click handler back on. So next thing is with our AMD modules, we have a new tool for building JavaScript. So we used to use Shifter for UI, but now we have a new tool called Grunt, which will, if you run Grunt at the top of the Moodle directory, it will look through all of the Moodle installation. And if it finds any UI modules, it will run Shifter on them, and if it finds AMD modules, it will run Uglify on them. So you don't need to think about what build tool is. You could just run Grunt and it will handle both kinds of modules. We're going to be adding more build things into this Grunt task so that it will also compile your less in your themes for you. And anything else we need, Grunt is going to be the tool that we put everything into so that developers don't have to learn lots of different tools. So you will notice that this is running Shifter first. Shifter is quite fast, but there's a lot of UI code in Moodle, so it's compiling 98 modules at the moment, which takes about a minute. So I briefly mentioned UI there. So UI used to be the framework, JavaScript framework that we used for creating dialogues and widgets and DOM manipulation in Moodle. It's quite a good library and it's been very stable since we've been using it. But towards the end of last year, I think it was, Yahoo just announced that they were going to be no longer releasing new features for UI. So they were still fixing bugs, but they're not adding any new features because they're not using it for any of their new products. So because of that, we've started this transition away from UI to jQuery and AMD modules as a future-proofing for Moodle. So we're going to be slowly converting our existing JavaScript and we're going to be writing all our new features using AMD and jQuery. So that just ran and built all of the AMD modules and all of the Shifter modules in Moodle using those two tools. So what we can see is in our AMD folder, we now have a build folder, and the build folder just contains the minified version of the JavaScript that we had before. When we're developing with AMD, there's a Moodle config setting which is case.js, and if you have case.js turned to false or off, then when you're making changes to your AMD JavaScript, you don't actually need to run Grunt after every change in order to see it in Moodle. Basically, as soon as you change the source and refresh the page, it will show up in Moodle, which is good for development because it's nice and agile and fast. And you don't need to run a watch command or anything like that. So where are we now? We have shown the JavaScript, we've shown the template, and that's it. It's really quite simple. Once you get to this point, this is So the first time the page loads, it renders it with PHP using that simple template. The data for the template is coming from the exact same web service that we were just looking at. So this is where the data for the template comes from. Calls that external web service and adds in this extra key. So that rendered the page in PHP, but when we click this button, that's not rendering the page in PHP, that's re-rendering a part of the page in JavaScript. So you notice that actually it works quite quickly. If I reload the whole page, because reloading the whole page needs to do a lot more work. It needs to set up all of the page, it needs to put the JavaScript in the footers, manage all the CSS, manage all the theme things. So it's much heavier request when you're re-rendering the entire page as to just fetching some data. So it's not even fetching HTML from the server, it's just fetching the data from that web service and rendering the HTML in the browser. So that is a lot faster. So when we're clicking that button, what we can do is actually see what's happening. So here we're showing the network requests. So if I do that, we'll see it made one very small network request. The data was really tiny. And here's the data that came back in JSON format. So we can actually see all the different properties of the data that was returned from the web service. And we could have had any of these things in our template as variables, and that would have printed them out. And this is our current time with the random number put on the end. So the other thing you'll notice is that it didn't make a request to load the template. That's because all the templates and strings are cached in browser local storage. So they'll only ever get loaded once per browser until that site gets upgraded again. When the version number changes, that causes those local storage caches to get purged. So the other thing to talk about is now that we are pushing people to write their plugins using external functions, that's good for a lot of reasons. So one of the reasons is that it means that the mobile app and will have access to all the same web services that you're using for your JavaScript. So you're more likely to write useful web service functions if you're using them yourself to build your own interface and to think of all the possible web service functions that you might need. This is sort of before, what used to happen is people would write their HTML pages, which were just directly calling PHP functions containing all the logic, and then later on someone might decide they need a web service, and because those PHP functions weren't designed with a web service in mind, they weren't suitable to be called directly from a web service. So we had to duplicate all that logic in the web service, and we ended up with the exact same thing done in two different places, which then obviously, if bugs get fixed in one place, people forget to fix them in the other. There could be security holes because the capabilities are mismatched, things like that. So the new, by putting an emphasis on external functions, it means that we're basically going to be getting people to write one nice clean API that can be used by both JavaScript and web services, which will make things a lot nicer in the future. So we've already been using this structure in the work that we're doing on learning plans and competency frameworks. And it works really well. So the way that we have it set up is we have in the classes folder for our new plugin, we have just a simple file called api.php, which is an API class which calls all of our internal functions which aren't meant to be exposed as an API. All our internal functions are in a subfolder for they're basically things that map to our data model. All of the permission checks happen in our api.php file, and then our external.php file is just a list of wrappers around the api.php file. This sort of three-layer separation means that we can write unit tests for the low-level internal functions, we can write unit tests for the higher-level API, and that api.php provides a very clear interface that other parts of Moodle could call those functions without having to go through the external functions layer, which the external functions layer just adds some overhead because it checks all the types of the inputs and outputs, which you don't need when you're calling directly from PHP, which is why that external.php just becomes a wrapper around api.php in our setup. And it works really well, and we have unit tests for everything. The interface is fast, and it's easy to build new pages, and it's easy to reuse parts of the pages in other places because the template can just be included. So I think that covers most of the things that we talked about at the Hackfest. There were a lot more questions and a lot more interaction there. Unfortunately, I just forgot to record it. I should have recorded that session, but it slipped my mind. So hopefully this captures most of what was talked about in that session. Thanks for listening. I'm sure you have heard lots of things and you're keen to go and play with them. So thank you.